Good morning, good afternoon, good evening, whatever time of day you're watching this. It's been a while since I've done a bit of a sit-downy kind of properly constructed video rather than me just belting about all over the place, which I either seem to be doing or I'm at my desk doing, report writing, which isn't really much of a video. So I thought I'd actually make a bit of an effort, put together a video today, which is going to be on using damp meters and on rising damp. So a damp meter seems to get a lot of bad press. Possibly for good reason. I think a lot of damp meters are misused. So I'm just going to run through what we as a firm use. We use one of these. It's a Protimeter MMS3. We've got the MMS2 as well. Got no idea what the difference is because as far as I can make out, they seem to do the same function. Now most of these meters have got pin probes. I don't actually use those that much because I find those to be not particularly accurate, which I'm going to come on to. And it's also got a bit of a scan function on the back. Theory being that if you put it up against something where there's damp in it, you'll get a reading. And these are color coded: green for good, amber for not so good, and red for damp, allegedly. These don't actually measure damp. I think that's reported in a lot of places. They measure electrical conductivity between the 2 points and a similar kind of thing along the back. I think one of the reasons why they get bad press is not so much the machine, it's the manner in which it's used. Sticking one of these into a wall with the pin probes and getting a high read and saying, yep, there's rising damp, is completely unacceptable. We're 2024 now. We should not be sticking pin probes in a wall to diagnose something like rising damp. And I'm going to show you later how you can get false highs through inappropriate use of one of these machines. So if they're not very good, why do we use them? Well, there's two things that I think are actually very good about these. First of all, forget damp readings. They're electrical conductance. So if they record electrical conductivity across the pin probes, however you use the pin probes, across those two, I normally use a thing that's stuck in the side so I can prod it about into timbers all over the place. If you invert the thought of these and think of not as a damp meter but as a dry meter, everywhere these recorders dry, it is dry. There's nothing to pick up electrical conductivity between the two pins, so it will be dry. That's the simple thing. The more complicated matter is if you do get a reading. Now, in my own opinion, that reading could be a whole host of reasons why, and dampness is only one of a whole host of reasons why you might get a high reading. So if we consider something's dry, it is dry regardless. But if it's a high reading, then that should just give you information that you can then use for further tests, for further investigations to find out why you're getting a high reading. Sometimes it's going to be damp, but quite often it's going to be other issues. If it is damp, let's assume that we are going to find some damp today. Those pin probes will not tell you what kind of damp. All they will say is there's electrical conductivity between the two. And if you conclude that it is due to dampness, you then need to find out what kind of dampness. There is no way on this earth that this machine, or any one similar to it, can diagnose the difference between condensation, rising damp, penetrating damp, a pipe leak, or anything like that. All it can do is tell you that there's a high reading between the two pin probes, which you've then followed up to diagnose it being damp. That, however, is only one of a few functions on these machines. What we use them for mainly, and I'm going to put the camera in a different position because there's a lot of additional functions on this machine that you don't get on smaller, cheaper damp meters. I mean, this is £1,000, and I'll go through those now quickly. So on our main menu, we have got our pin probes, which is our two bits at the top. We have got pinless moisture meter, which is our scan function on the back. And then we've got hygrometer and psychrometrics. So these are the ones we use most, and surface temperature probe, but I don't really use that, and I'll come back to that. We've also got other bits and pieces there as well. So if we look at psychrometrics, this is where we're starting to actually work out what's going on in a property. So here in this room right now, our temperature is 26.1/2 degrees Celsius. And our dew point is at 16.9. It's going up and down a little bit, so just got this out of the van. So what that essentially means is when the temperature in this room drops to 17.3 right now, any moisture in the air is going to change from moisture vapor to moisture droplets. So condensation is going to occur. And we can see here as well is our relative humidity, but I'll come back to that in a moment, because relative humidity is not as accurate as people think it is. So what we've also got with this machine, so these two points, dew point and the temperature, are absolutely critical. What we've also got in here is a surface temperature, an infrared temperature, which we get by pressing this button, and I'll press it against the desk. And there we go, we can see our button, we can see our thermometer. So the desk, if I can get these in the same picture, the desk surface temperature is 22 degrees. So what that tells me, I'm actually going to point at the ceiling now, it's about 22 still, is our air temperature right this minute. So sorry, our dew point is 16.6 and our surface temperature is 22 degrees. So there's a 5.4 degrees difference between the two. So we are a long way from condensation being an issue in this room. If that surface temperature was down at 17 degrees, we would only be right at this particular point in time, 0.1 of a degree, well, we've been matched now, but 0.1 of a degree from condensation occurring. So we are at risk of condensation. But if at any point that surface temperature drops below the dew point, so it goes down to say 15 or 16 degrees, condensation is occurring. And then we've got a damp issue. We'll find this in loft spaces, we'll find it on external walls, sometimes internal walls, certainly below floors. So this is a critical part of this machine, which is all part of this overall one machine. Absolutely brilliant, and it can give us a snapshot at a particular time. Obviously right now, so I don't know what it is, 1 or 2 o'clock on a Thursday afternoon or something. We can see exactly if there's a condensation issue at that particular point in time. So that is a really useful function of this machine. Next thing to look at is our relative humidity. Now, relative humidity, generally people say if it's above 75%, it's damp. But that really depends on what your temperature is, because relative humidity is how much moisture that air can hold at that temperature. So at what this is saying, these two figures right here, is that at 26.4 degrees Celsius, the air is currently holding 55.2% of the maximum moisture content it could hold. So taking that forward, if we was to have a chart that looked something like this, and that was our percent relative humidity. Can we see that on the chart? Yes, we can. Let's just alter the camera slightly. And this is our temperature in degrees Celsius. So let's go 5, 10, 15, 20. And let's go 60%, 65, 70, 75. Now this isn't absolutely accurate, but a psychometric chart would do exactly this function and it would be more accurate. Now let's look along the bottom of our absolute temperature, relative humidity, our absolute humidity, and let's say that our absolute moisture content is 11 grams per kilogram of air. Now, that 11 grams is an absolute figure, regardless of what the temperature says or what the relative humidity says. That is how much weight of air there is per kilogram of air. So potentially at 5 degrees Celsius, that might equate to 72% relative humidity. Now, the warmer air gets, the more moisture it can hold, so it could potentially hold a lot more than that. So if we consider this to be like a little seesaw, and the temperature then went up to 15 degrees on that same 11 grams, our relative humidity might only be 58%. So without changing the actual moisture content of the air, our relative humidity could swing up and down. And that's going to be dependent on the time of year, the time of day, and general environmental considerations like that. So that's really important to consider. So on this unit as well, we also have grams per kilogram. And here we are 12.1 grams per kilogram. That's quite a moist environment indoors, but it is summertime. So there is going to be quite a bit of moisture in the air because the air is warmer, it can hold more. So these are the more useful functions for a machine like this. Now, when we're doing damp inspections, we'll then use other machinery as well. So when we're doing damp investigations, normal stage for me personally, disagree if you like, I'm not fussed, but the way I do it is I'll have what I call general scope around. So I saw recently on a Facebook page that someone shared this photo that said this was part of a moisture map. It isn't, in my opinion. It is a picture of a damp meter held against a wall that's showing a very high figure. But then further investigation needs to know as to exactly why that figure's occurring. When we do a moisture map, it looks more like this. And we can quite clearly see in this photo that we've got some green, some amber, and we've got some red some red numbers as well. So not really all that considered about what the numbers are. If it's 735 or 999, does it really matter? Not particularly. But if it's green, it's dry. We've established that. It won't pick up anything. But if it's red, it could be picking up damp. It could be picking up other issues. But this is for us as surveyors, as a chartered building surveyor, to look as to why that's red and why there could be an issue. And in this particular scenario, there was a leaking gutter on the outside, saturating the wall, which caused those red figures to occur, which were where we had our our peeling wallpaper. So our first step is to scope about. We'll then use a thermal imaging camera. And here's my cheapy one I bought off Tinternet. This is a HIT HT-H8. It's a great little camera actually. I've had it for probably about a year or so now. Might have broke my other two. One was a Fleur E40, which had picture-in-picture function, which was absolutely brilliant. This doesn't see inside things like people say it does. What this does is takes the temperature in loads of pixels, the surface temperature of something, and then converts that into a colour. So you can, in theory, see behind stuff. It's going to be difficult today because everything's warm. But we're in a timber framed office, ceiling joists, 400mm of insulation up in the roof. And in the winter, using this, you can see where all the ceiling joists are. Because where there's a ceiling joist, there's effectively only 200mm of insulation above it. And in between, you've got 400, because I put 200 between the joists and 200 over the whole lot. So in that element, in that respect, you can see into things. What our human eyes can't do is we can't see thermal either. So what that does is, because it has different colours, or you can have grayscales or present it how you like, generally areas that are cooler come out different colours to areas that are warm. So if I can, I'll show you in a minute on another worked example. Okay, and then, so we've got other bits and pieces and tools and that we use as well, but my particular favourite is the carbide meter. What this does, this is a pressure vessel. So we put a weighed sample, it's only 6 grams in this one, a weighed sample in there of plaster, brickwork, blockwork, whatever it is we're testing, concrete. And then we put 2 scoops of calcium carbide reagent into the lid. Now that has to go into the lid, because if we put it in there with the sample, the reagent will react with any moisture that's in here and will start to produce acetylene gas. That will then potentially start to pressurize this before the lid's on, so it's not actually producing any pressure at all. But I'll go through this in a minute as we do a sample and a damp inspection we've got to do. So I've used it in a video before. I've got some calcium carbide, but it came in chunks, so up to 10mm. It's horrible stuff to use, and I've since got some powdered version. So what this does, when calcium carbide reacts with water, it produces acetylene gas, and it's that gas that charges pressurizes the vessel, and that's calibrated obviously, so we can get exact moisture contents. But if I get a little chunk, pop it in water, get quite a vicious reaction. And as I say, this is acetylene gas, so it's actually flammable as well, and that'll just burn off all the time the gas is actually coming out of the being released from it. So that seems like a bit of a quick whiz through some of the machinery we use, and I thought I'd do this today, partly because I haven't done a video for a while, but also partly because I've been asked to have a look at a damp issue in a property that's been there a while, and they want to know what needs to be done, because they've had the usual people come round, pin probes, it's rising damp. So we're going to have a look at that now. So we're in this property, it's a lovely old property, but the clients reported, dogs have just heard me, clients reported this damp stain in here. So the top of it flows just along this line and then kind of drops away quite quickly. So I've been asked to look at and diagnose what this issue is and what needs to be done to put it right. So normal thing, what we first do is we would get a damp meter out and we'd scope about. But what I fear has happened, and it's certainly happened here in the past, and it happens way too much in my view, surface pin probes all at rising damp, all yet really high. We've absolutely got rising damp. It's not gone too far up the wall at the moment because that's not even picking up anything, but here we've got absolute classic case of rising damp. However, if we look very closely, the paint's not failed. There's no issues to the skirting at all. And there's no signs of blistering or absolutely anything that could give us an indication that there's a real damp issue going on here. So surface pin probes are giving us some information, but what do we do with that information? So let's then look at our pinless moisture meter. So yeah, really high. Again, really high. So all these in our damp area, it's come up really high. But as soon as we're outside our damp area, very low. And once again here, in our damp area, really high. And if we get just above it, it's starting to drop off. Then we're really quite low. So it really is just this area here. So damp-proof course failure, possibly. I'll come back to that. This is an inside wall, but once upon a time it was an outside wall. There's a kitchen extension being built on the back. It's an old flint building. So perhaps next step, let's see what the thermal imaging says. So onto our thermal imaging camera. Here we've got fairly consistent across the whole wall. Nothing to indicate that up here we're absolutely bone dry, but down here we're absolutely saturated. So a little bit cooler on it's cooler on the floor and the skirting, but it's a concrete floor, uninsulated, and this is an internal wall, so that's exactly what we would expect. So now we've actually got contradicting information. We've got thermal imaging that says, well, there's no issue here. Just to look at that again, that's the floor, slightly different band is the skirting, then we're into the wall. So we've got thermal imaging that's not picking up anything, yet we've got two different forms of damp meter, or two different forms of readings on our damp meter, that are both saying we've got an absolutely saturated wall. So there's now only one thing for it, and that's to drill into the wall to take a carbide reading. Now carbide will give us an absolute moisture content of this brickwork, plasterwork, blockwork, whatever it is, and then we can ascertain from that whether it's actually damp or not. So I've got myself all set up. I've got my scales, my speedy, my scoop, my reagent, and somewhere a little tub to measure my weight into. This requires destructive testing, so I've actually got to drill into the wall, which a lot of people aren't happy to do, particularly on a pre-purchase survey. So chances of being able to accurately identify damp on a pre-purchase survey in this manner is going to be extremely unlikely. But when you look at someone's property, they've got a damp issue, quite often they're a bit more happy for you to do it. So let me make a start. Okay, so let's get that weighed. 6 grams is what I'm after. It might be a fraction under, but we'll see. Reset the scales. See, this is coming out looking very, very dry. So I'm not sure we're going to find a damp issue here at all. Just drill a bit more. There we go, 6 grams, absolutely bang on. So what I'm going to do is undo my speedy, set my lid aside, and I'm going to put my sample in the chamber. So that's in the chamber out of the way. I do not want to mix the sample and the reagent just yet, because as I said in the other video I did yesterday, is that it's going to prematurely cause a chemical reaction to occur. And we don't want the gas escaping out the top, because that's just going to give us a false low. So we put the sample in the speedy and we put the reagent into the cap. That then goes on there. They're still not mixed, so that isn't a problem. And then we're just going to do our cap up. Now, as I said yesterday in the other video, not the other video, earlier part of this one, but as I said yesterday, they're still not mixed, so it's 0. The reagent will react with any moisture that's in our sample, and what that will do is it will pressurize this cylinder, giving us a reading. So let's get those mixed. So that's now, they've all fallen into the lid, so they're all getting mixed up in there. Give it a good shake, a real good shake around. Now what I'm going to do is I'm going to have a tidy up, and I'm just going to leave that to set on its own and to record a reading. Okay, it's been in there about 10 minutes and that's recording 2.8. So what we'll do now is we'll go back and look at, in the office, we'll go back and look at technical information as to whether that is actually damp or not. Part of what we do, we're chartered building surveyors. Well, I'm a chartered surveyor and I've got another chartered colleague that works with me. The information that we gain, the damp meter readings, the carbide readings, the thermal imaging, that tells us one thing. What it doesn't tell us is, well, what's up here, and this is what we need to consider. This is our knowledge as to what's going on. So back in the office, we'll use various data. Protimeter produce a lovely little chart that tells you at what level things are considered damp. PAS 64, which is about water mitigation measures and drying of buildings post floods. They've also got charts in there that kind of link up with that as well, and there's going to be others in various British standards as well. And what we can see by this chart here is that it shows brickwork, generic brickwork, should be around 2.4, 2.8 or so to be considered dry. Beyond that, we're into the potential wet zone, or damp, should I say. And our reading, I think, was 2.8. So we're just kind of creeping into that. So let's then consider the building as a whole as to why in a pretty dry building, we're getting a small isolated area of damp that our client thinks is rising damp, because that's what she's been told by someone else. So I said that this wall used to be an external wall. There's a chimney here. There's no ventilation to the chimney at all. So the readings are ever so slightly elevated. We'd want that below probably 3.5 or so. But what we can see here is if we pop an air brick in, it's probably it's a condensation issue, and that's giving us our very slightly raised damp reading. What's giving it the very high readings is an old chimney stack, and there's salts just in the wall, so that's giving us our effectively a false high. So my recommendations will be pop an air brick in here, make sure the top is capped and ventilated, job done. Okay, there we are. So we'll review all the information we got to hand. We're looking at our high ultrasound or scanning readings, our high pin probe readings. We're looking at our negative, if you like, thermal imaging. We're looking at our relatively low, but not absolutely low, carbide readings to see why we've got this one damp issue on an area of wall. And we found it to be the base of an old chimney stack. So we've got the salts migration through the gypsum plaster as well, giving us effectively false highs on the protimeter, on the damp meter, on the electrical resistance meter, whatever you want to call it. And then because it's an old chimney stack with no ventilation, we've probably got a little bit of build-up condensation in there that has given us a very slight high reading. So we do not need a chemical DPC. We do not need to replaster that wall with expensive specialist plasters. Okay, it's an older property, it's a gypsum plaster, may not be particularly ideal, but it's one small area. We wouldn't even recommend replastering, but we would recommend popping an air brick, ventilate and cap the chimney stack. And that's all you need to do. No super expensive works. She said it's been like it for years. It can probably stay like it for another couple until they're doing some works outside and those repairs can be done. So I hope you found that useful, informative, educational, whatever. Please ask any questions, you feel free to, and I'll see you on the next one. But thank you for getting this far, and if you like what we're doing, please like and subscribe to our videos, and I'll see you on the next one.